Taiwan is a tiny island nation with less than 2% of the world's population. Yet it controls over 60% of the global chip manufacturing and more than 90% of the advanced nodes below 7 nanometers. On the other hand, India, with one of the largest talent pools in engineering, still does not have a single commercial chip fab. Why the huge gap? Let's take a journey through the TSMC's rise and understand why India fell behind. First, let's understand the Taiwan's journey and the rise of TSMC. Firstly, visionary leadership. We manufacture, you design. Let's both specialize and win. That was the motive Morris Tank followed. A PhD from Stanford worked at Texas Instruments for 25 years. TSMC was invented by Taiwan's government in 1985 to lead its semiconductor initiative. It is founded by the Taiwan Semiconductor Manufacturing Company in 1987. A revolutionary concept was made for the first ever pure play foundry manufacturing only, no design. Next comes strategic government policy. Taiwan's Industrial Technology Research Institute, or ITRI, nurtured talent and research. The government invested heavily in Hsinchu Science Park like Silicon Valley, semiconductor R&D labs, engineering colleges like NTU, NTHU, and NCTU, and provided capital, land, tax breaks, and guaranteed orders. That's what helped them. Thirdly, innovation and scaling. TSMC's success was due to advanced processing nodes leading the world in 7 nanometer, 5 nanometer, 3 nanometer, and 2 nanometer. Early partnership with fabless giants like NVIDIA, AMD, Apple, and Qualcomm also gained their profits. The constant reinvestment of around 8% of revenue in R&D annually, that was an innovative idea. Next comes building global dependency. TSMC produces chips for Apple, AMD CPUs, GPUs, NVIDIA GPUs, MediaTek, Qualcomm, etc. Apple alone accounts for 25% of TSMC's revenue. Now let's come to the next part of this video. Why India still lags in chip fabrication. Firstly, late to the game. While Taiwan builds fabs in 1980s, India focused on software services like Infosys, TSES, etc. And BOP and IT experts, India lacked those. Early attempts failed in SEM India 2006 and HMC 2013, which are collapsed now. Secondly, infrastructure bottlenecks. A chip fab needs pure water, millions of liters per day, uninterrupted power supply, clean rooms, skilled workforce, global grade logistics, etc. Next comes talent export and brain drain. India produces 1.5 million plus engineers per year, but the best talent moves to US or Taiwan or works in design roles at Intel, Qualcomm, Cadence, Synopsys, etc. Fabless design exists in India, but fabrication never matured. Next comes high cost and low confidence. Leading edge fab costs around 10 to 20 billion dollars, requiring long-term commitment and risk-taking capital. India lacked deep tech VCs, strategic vision, and industry alignment. Now let's look into what is India doing right now. Firstly, government initiatives, PLI, DLI, Semicon India, etc. $10 billion initiative scheme, Semicon India program have been invested. PLI for compound semiconductor, ATMT, and OSAT. This initiative focuses on attracting global foundries like TSMC, Tower, Foxconn, UMC, etc., and also local design ecosystem like fabless startups. Next comes major projects underway. Vedanta Foxconn Gujarat facing delays, Tata Group and Powerchip Taiwan most promising 65 nanometer mode, Dulera, Micron assembly and testing plant Gujarat construction started, ISMC Tower and Next Orbit paused. India has everything it takes brains, ambition, government push. But catching up with Taiwan requires at least 10 to 15 years of consistent investment, policy continuing, and industry academic collaboration. We may not be beat in TSMC, but we can become a strong alternative, especially in legacy nodes like 65 nanometer or 28 nanometer, packaging, and compound semiconductors.